inverse secant and cosecant have those concave up and concave down pieces. The range is negative infinity to infinity, except for that strip in the middle from -1 to +1, where secant and cosecant don't have any values. So the domain for inverse secant and inverse cosecant is negative infinity up to -1, and then 1 to infinity. Now that's the domain of the inverse functions. What about the range of the inverse functions? 3 of them give you from -π/2 to +π/2. That's fourth and first quadrant. 3 of them give you from 0 to pi. That's first and second quadrant. Tell me which 3 give you an angle between -π/2 and +π/2. Sine, and if you can remember sine, then what else has to have the same range? Cosecant, because it's just a reciprocal of sine. So sine, cosecant, and one other give you an angle between -π/2 and +π/2. It's tangent. Sine, cosecant, and tangent give you an angle between -2π/2 and +π/2. Cosine, cosine, secant, and cotangent give you an angle between 0 and pi. All right, you do have to know those. And then after that, it's just practicing, learning to work backwards. Now, it would be natural to think that, for example, cosine of inverse cosine of 3, the cosine and the inverse cosine would undo each other and just leave you 3. I mean, that makes sense, right? That's what inverse functions do, except you can't take the inverse cosine of 3. Tell me why you can't take the inverse cosine of 3. You can only take inverse cosine of numbers between
-1 and 1.
-1 and 1. So you can't say cosine of inverse cosine of 3 undo each other and leave you 3, because you can't even take the inverse cosine of 3. And one other thing, if I say inverse cosine of 3/2 pi, they can't undo each other and leave you 3/2 pi, because 3/2 pi is not an answer inverse cosine can give you. Inverse cosine can only give you answers between 0 and pi. So what I'm trying to prepare you for, what we're fixing to look at in the book, it's not always true that trig and inverse trig undo each other. There are caveats that you have to pay attention to. So let's look at the blue box on the notes, say page 629. First, the sine function and its inverse. You can say sine of inverse sine undo each other and just leave you x, as long as x is a number you can take the inverse sine of. Let me get my highlighter here so I can feel like I'm pointing at something. All right, sine of inverse sine of x undo each other and just leave you x, as long as x is a number that you can take the inverse sine of. That means x has to be a number between -1 and 1. Inverse sine of x undo each other and leave x, only if x is an angle that inverse sine can give you. That means x is between -π/2 and +π/2. Cosine of inverse cosine of x undo each other and leave you x, only if x is something that you can take inverse cosine of. That's x is between -1 and 1. Cosine of inverse cosine of x leaves you x if x is an answer that inverse cosine can give you. That means if x is between 0 and pi. All right, this seems like a lot more to memorize. So I tried to sum it up generically. I'm not even going to read this last one because I summed all three properties up generically right here where I've said think. It has to do with what's your outer function and what's your inner function. If your inverse trig function is your inner function, you see why I'm calling that inner function? And the trig is your outer function. In order to say that they undo each other and just give you x, x has to be something that you can take the inverse trig function of. Now that depends on what the inverse trig function we're talking about. But if it's inverse sine or inverse cosine, then x would have to be a number between -1 and 1 or the whole thing blows up. That's when the inverse trig function is the inner function. X must be in the domain of the inverse function. That is, x must be a number that you can take the inverse trig of. And then if inverse trig is your outer function, then x has to be a number that that inverse trig function can give you. You can't say inverse trig of something undo each other and leave you x if x is not an answer that inverse trig can possibly give you. Now, this is still going to be brain taxing, but I've tried to tell you in the next examples exactly the words that you need to think before you say, oh, these two undo each other and just leave you x. So let's look at some examples. My inner function here is inverse cosine. In order for me to say cosine of inverse cosine of 0.6, I have to ask myself, is 0.6 a number I can take inverse cosine of? Is it? What can I take inverse cosine of? Anything between -1 and 1. So is 0.6 between -1 and 1? Yeah. And since it is, then cosine of inverse cosine of 0.6 just undo each other and leave 0.6. Now, if every problem was just like that, then the whole previous discussion was unnecessary. We could just, whenever we see trig and inverse trig next to each other, we can just cancel them out. Well, it's not always that easy. Let's see why it's not. And the B part, our inverse trig function is the outer function. So our answer has to be something that inverse sine can give us. Excuse me. Inverse sine can only give us answers between what and what? -pi/2 and +pi/2. So in order to say these undo each other and leave me 3/2 pi, I have to think, is 3/2 pi an answer that inverse sine can give me? Is it between -pi/2 and +pi/2? No, it's not. So this answer cannot possibly be 3/2 pi because that's not an answer inverse sine can give me. Now, sometimes there's a workaround and sometimes there's not. In this case, there is a workaround. I can say sine of 3/2 is what? Sine of 3/2 pi. Where is that on the unit circle? Negative y-axis. And what is sine down there on the negative y-axis? We just should start every class by doing that and labeling it. Here's 3/2 pi. Sine is your y value. What is y right there? -1. So even though I can't say these undo each other and just leave me 3/2 pi, I can do part of the problem. Sine of 3/2 pi is -1. And then I can take inverse sine of that. What is the angle between -pi/2 and +pi/2 where sine is -1? This is one place that sine's -1, but it's just not the way we can write the answer to an inverse sine problem. What's another name for that angle so that it is between -pi/2 and +pi/2? Yeah, if we just call it -pi/2, it's the same answer with a different name. All right, you see why the answer cannot be 3/2 pi? Give me a thumbs up if you can see why the answer cannot be 3/2 pi. Hallie? Well, actually, Hallie, you're the one, I think you're the one who told me inverse sine can only give me angles between what? Okay, 3/2 pi is right here. And that ordered pair is 0, -1. So what is sine of 3/2 pi? Okay, so that's how we got that. All right, because we were able to evaluate this inner thing, then I'm just putting this in the place of 3/2 pi, or not 3/2 pi, but I'm putting that in the place of the whole sine of 3/2 pi. Sine of 3/2 pi is -1. So I just put -1 in place of that inner function. And then I said, what angle has a sine of -1, but is between -pi/2 and +pi/2? It's the same angle, but we just needed to write the answer in a way that it was between -pi/2 and +pi/2. Yes, yeah. We were just giving it a different name, a name that fits the rule, and the rule is it has to be between -pi/2 and +pi/2. Okay, glad that clicked. Let's do another one. Cosine of inverse cosine of 1.5. In order for those to undo each other and just leave me 1.5, I have to think, is 1.5 an answer that I can take the inverse cosine of? No, because it's not between what and what? It's not between -1 and 1. So is there a workaround like the previous problem? The previous problem, even though we couldn't just say these undo each other and leave me 3/2 pi, I could work the inner function and then apply the outer function. Can I do that here? Can I work the inner function? No, there's no way to fix that. You can't take inverse cosine of 1.5. So you would just have to say that's undefined. Nothing you can do about it because you can't work the inner function. All right, what about tangent of, inverse tangent of 380? You have to think, is 380 an number that I can take inverse tangent of? Well, then you have to think, well, what kinds of numbers can I take inverse tangent of? That's what inverse tangent will give me an answer as an answer. But I'm saying, what can you take inverse tangent of? Remember, the domain of the inverse function is the range of the original function. So what's the range of tangent if you graph it? Tangent goes from negative infinity to infinity. That's the range of tangent. So that's the domain of inverse tangent. You can take inverse tangent of anything. So what's tangent of inverse tangent of 380? Yeah. Because 380 is a number you can take inverse tangent of. I think that sentence might get me a bad grade in comp. Is it? Are you okay with it? It's between negative infinity and infinity. I can take the inverse tangent of anything.
Is it because the range or the domain of inverse tangent is negative?
Yes, you can add that. That's perfect.
So when we first look at the problem, we're looking at what's in the parentheses to ask the question to ourselves.
I think the better way to think of it, Hallie, may be whether inverse trig is your inner function or your outer function. If inverse trig is your inner function, then that argument has to be something you can apply that inverse function to. It has to be in the domain of the inverse function. And that's what I was trying to say right here. If inverse trig is your inner function, then x has to be in the domain of the inverse function. It has to be something you can take the inverse trig of. But if inverse trig is your outer function, it's the last thing you're going to do, then your answer has to be something that that inverse trig can give you. It has to be in the range of that inverse trig function. Now, nothing I can say will make this perfect in the next hour, but you'll get it. I know you, I know how smart you are, I know how hard you work. You'll get it. It's just going to take some practice. All right, so the E part. My inverse function is my outer function. So whatever my answer is, has to be something that inverse tangent can give me. So now I'm looking at the E part again and going, is 3/4 pi an answer that inverse tangent can give me? Inverse tangent gives me answers between I may have to make you some flashcards. Put the inverse function on the front of the flashcard and its domain and range on the back. Until you can just flash them and go, I know inverse tangent has to give me something between, have you thought of it yet? Negative pi over 2 and positive pi over 2. Sine, cosecant, tangent, all give me answers between negative pi over 2, positive pi over 2. Cosine, secant, and cotangent all give me an answer between 0 and pi. And you just have to know those. All right, so is 3 pi over 4 an answer that inverse tangent can give me? It's not between negative pi over 2 and positive pi over 2. What quadrant is 3/4 pi in? That's the second quadrant, quarter pi. And can I do the work around here? Can I work the inner function and then apply the outer function? Yeah, I can tell you what tangent of 3/4 pi is. At all the quarter pies, tangent and cotangent are either what or what? 1 or -1. Because the x and y at all the quarter pies are either the same or opposites. So at 3/4 pi, would tangent be +1 or -1? I'm thinking 3/4 pi is right here. And that would be a negative divided by a positive. Actually, y divided by x would be a positive divided by a negative. So right there, tangent is -1. So I'm just going to put -1 in the place of the whole tangent of 3/4 pi. I've worked the inner part of the function. Now, is there an angle between -pi over 2 and positive pi over 2 where tangent's the same, -1? Would that be in the first quadrant or the fourth quadrant? In the fourth quadrant, what's that angle in the fourth quadrant where inverse tangent, or where tangent would be -1? We're used to thinking of it as 4/4, 5/4, 6/4, 7/4 pi, but 7/4 pi can't be the answer for the same reason 3/4 pi can't be the answer. It's not in the range of inverse tangent. But Emma said, well, that's the same as -pi over 4. And that is an answer that inverse tangent can give me. Three-fourths pi is not an answer that inverse tangent can give. 7/4 pi is not an answer inverse tangent can give, but -pi over 4 is an answer that inverse tangent can give. All right. F is cosine of, inverse cosine of 3 pi. Can I say those just undo each other and leave me 3 pi? No, why not? Give me the right reason, no. The 3 pi is what? It's not in the domain of inverse cosine, because what numbers can I take the inverse cosine of? -1 to 1, and 3 pi is getting close to 10. I can't take the inverse cosine of 3 pi. Can I do the workaround where I work the inner part and then no, nothing I can do about this, because the inner part is taking the inverse cosine of something that's about 10. That's not possible.
Are you looking at the domain when you're trying to see if you can use that number in the range to see what the outcome would be?
Yes.
Okay.
Yeah. Okay. And I don't know a better way to put it than I did right here. It just has to click in your head. And it just clicked for Emma. If inverse trig is my inner function, then my answer has to be in the domain of that inner function. If inverse trig is my outer function, then my answer has to be something in the range of the inverse function. All right, one more. I couldn't do the F part because 3 pi wasn't between -1 and 1. What about the G part? Can I take inverse cosine of 2 pi and say they just undo each other, so the answer is 2 pi? No, but it's for a different reason. It's not because 2 pi is not between -1 and 1. It's because 2 pi is not between what? 0 and pi, the answers that inverse cosine can give me. So it can't be, I should say this whole thing cannot equal 2 pi because, excuse me, 2 pi is not in the range of inverse cosine. It's not an answer inverse cosine can ever give me. So my next question is, so is this undefined? Or is this, hey, I can do the middle, I mean, do the inside and then apply the outside? I can tell you what cosine of 2 pi is. What's cosine of 2 pi? It's 1. So I need to find an angle that is between 0 and 2 pi, excuse me, between 0 and pi, inclusive, where cosine's the same thing. What's another name for the angle where cosine is 1 other than 2 pi? You can also call it 0. And that is an answer inverse cosine can give us. All right. In the H part, is there any circumstance under which I could say sine and inverse tangent undo each other? No, they're not inverses of each other. Can I squint really hard and tell you or evaluate this inner part? Can you think of an angle whose tangent is 7/24? No y divided by x that I have memorized on the unit circle is going to give me 7/24. But should that have an answer? Is there an angle whose tangent is 7/24? I can take inverse tangent of anything. So this has an answer. It's just not something I have memorized on the unit circle. So I have two choices. If it's okay to use an approximation, a decimal approximation, I can punch inverse tangent of 7/24 on my calculator and then take the sine of that. But if these directions say find the exact answer, then I can't find that on the calculator. I'm going to have to sketch a triangle whose tangent would be 7/24. Now, inverse tangent can only give me an answer in which two quadrants? First and fourth. And in which one of those two would inverse tangent be positive? Yeah. So this is the first quadrant angle whose tangent is 7/24. Now this is not to scale. I didn't try to make it to scale. I'm just going to say if I drop a line down to the nearest x-axis and call this my theta, then which two sides of that triangle give me tangent? Opposite and adjacent, the 7 is the opposite, the 24 is the adjacent. So opposite theta is 7, adjacent to theta is 24. How do I find hypotenuse there? Twenty-four squared is 576 and 49. I just lost it. I think it's 25. I think it's 25, but I need somebody to double check that on the calculator. I think a 7, 24, 25 is a Pythagorean triple. It is, isn't it, Hallie? Yeah. So even though I can't tell you how many degrees or how many radians theta is, I can tell you what sine of theta is. What sine of theta? Yeah. I like being able to tell you something about that angle without even actually having to figure out what that angle is. I just draw the angle whose tangent is 7/24 and then find sine of that angle. This seems a little easier, right? Oh, that makes sense. Okay, let's do another one. I part is cotangent of inverse sine of, what is that, 5/13? Yeah, 5/13.
Really, really small, but it looks like there's negatives there.
I don't think so. I think that -1 is just inverse sine.
I think it's probably the printer.
Okay, yeah, I don't, mine doesn't look like it had a negative there. Can I say those undo each other and leave me 5/13? No way cotangent and inverse sine are going to undo each other. Can I squint really hard and tell you an angle whose sine is 5/13? That's not one of the angles I have memorized on the unit circle. So I can't tell you what that angle is, but I can draw a picture of it and I can tell you it's in what quadrant. Inverse sine always gives you a fourth or first quadrant, and it's first quadrant where sine would be positive. So I'm going to draw a first quadrant angle, call it theta. Drop a vertical line down to the nearest x-axis, and then label that right triangle in such a way that its sine would be 5/13. Using opposite, adjacent, or hypotenuse, tell me what that 5 is. That's opposite. What's the 13? Yep. If I can focus that just a little bit better. I don't know if that's better or not. Maybe a tad. Do I need adjacent for cotangent? Do I have to find it? Sometimes I don't even have to find it. But what's the definition in terms of opposite, adjacent, and hypotenuse? What is cotangent? I almost have to think tangent first. I go tangent is opposite over adjacent. So cotangent is adjacent over opposite. Yeah, I'm going to need to know what adjacent is then. And tell me, if I had to do it on the calculator, what would I punch on the calculator to find adjacent? Yeah, we're looking for one of the legs. So I have to do hypotenuse squared minus leg squared. 169 minus 25 is 144. Square root of 144 is 12. And I just happen to know 5, 12, 13 is a Pythagorean triple. So what's cotangent of this angle? Adjacent over opposite, 12 over 5. Now, I need to know how much time we have so that I know. Yeah, I think we can do 3 more. Yeah, in 18 minutes. Heck yeah. All right, J part. Secant of inverse sine of -1/2. There's no way that I can just say they undo each other and leave -1/2. They're not inverses of each other. So can I squint hard and tell you an angle whose sine is -1/2? Or do I need to draw a picture of it? Actually, that is one of the y values I have memorized on the unit circle. So inverse sine can only give me an answer between -π/2 and +π/2. That's fourth or first quadrant. In what angle is, or in which quadrant is there an angle whose sine is negative between these two? Quadrant 4. All right. We're narrowing it down. I know it's in quadrant 4. What is, with the angle whose sine is -1/2, first to sine x or y? It's your y coordinate. Would y be -1/2 close to the y axis or close to the x axis? Close to the x axis. Close to the y axis, your y is almost -1. Close to the x axis, your y is closer to 0. So that inverse sine of -1/2, I don't even have to draw a picture of it. I can tell you the name of that angle near the x axis is what? Yes. Now, another name for it would be 11/6π, but we can't use 11/6π because that's not an answer inverse sine can give us. We have to say that's -π/6. And then, you know what's bugging me about my drawing here is this is supposed to be the unit circle. And so this radius is supposed to be the same as that radius. This point would be more like there. This little math teacher thing bothering me. Now, those look like they have about the same radius. At this angle, -π/6, what's the ordered pair? X is almost back to 1. Y is -1/2. So when I'm looking at an ordered pair, how do I find secant? Secant's the reciprocal of which trig function? Cosine. Cosine is which coordinate? Your x. So take the reciprocal of your x. If you didn't have to rationalize it, what would that be? Yeah. Now for my math lab, you probably do have to rationalize it. I'm sure you do. On the test, I want you to spend your time doing other things, but that's 2 √3/3. And finally, the next 2 problems are 2 of my favorite problems in all of math, because I know what calculus involves. Calculus involves taking derivatives of stuff. And when I think of taking the derivative of sine of inverse cosine of 2x, it makes me want to change back to a PE major. And I hate to sweat. Okay, and I'll run and I'll jump. So that would be horrible to find the derivative of. If somehow I could change it to algebra, that's the bumper sticker on my card. Not really, but if only it were, actually the bumper sticker would say, if only it's transcendental. Let's get the 2 back. It is transcendental. 2 kinds of functions, algebraic and transcendental. Algebraic consists of x's and numbers and da, da, da. Transcendental is all your trig functions and logs. This is a transcendental function, and it would be horrible to take the derivative of. So I'm thinking, if only I could change it to algebraic. Well, think about what we did up here. I couldn't tell you the angle whose tangent was 7/24, but I could draw a picture of an angle whose tangent was 7/24. I can't tell you an angle whose cosine is 2x because I don't even know what 2x is. But I can draw a picture of it. In terms of opposite, adjacent, and hypotenuse, what is cosine? So what's the hypotenuse here? Sure. Can you label that triangle in such a way that its cosine would be 2x? Adjacent would have to be 2x. Hypotenuse would have to be 1. What does that mean opposite would be? It's still Pythagorean theorem. Hypotenuse squared minus leg squared would be what? I can't simplify it a whole lot, but I can name it square root of 1 minus 4x squared. So what is the sine of that angle that I just drew? Sine of that theta right there. Yeah. I'm up here having massive chill bumps and y'all just aren't duly impressed with how magnificent it is that you can change sine of inverse cosine of 2x to an algebraic expression. Whatever find the derivative means, I can tell you it'll be easier to find the derivative of square root of 1 minus 4x squared than it would be to find the derivative of that. I guess you're just going to have calculus to know how helpful that would be. All right, last one. Cotangent of inverse sine of square root of x squared minus 9 over x. Is x squared minus square root of x squared minus 9 over x one of the y values I have memorized on the unit circle? No, I don't even wish. I don't even wish that. I'd rather draw a picture of an angle whose sine is that. I think I can, because sine is just opposite over hypotenuse. I can draw an angle whose opposite is square root of x squared minus 9 and whose hypotenuse is x. I may have to squint a little to figure out adjacent. I bet you can do it just by squinting and not even having to write anything down. What would that adjacent have to be in order for this opposite to be square root of x squared minus 9?
9.
No, if it were 9, this would have to be square root of x squared minus 81. But you're close. That would have to be 3 in order for square root of hypotenuse squared minus leg squared to be square root of x squared minus 9. You see why, Dominic?
Yeah.
Okay, all right. You were on the right track, just had a little blip there. I would say just, if you're working in pencil, write down what you think it is and see if that would make a Pythagorean triple. See if x adjacent squared plus opposite squared would give you hypotenuse squared, and it will. So what is the cotangent, if we call this inside thing we just drew a picture of theta, then what is cotangent of theta? Which two sides make up cotangent? Adjacent and opposite. It's adjacent over opposite. Adjacent would be 3. Opposite would be square root of x squared minus 9. And my math lab will probably have you rationalize that. Tell me how you would rationalize that if you had to. Yeah, on the test, I wouldn't ask you to do this, but I want to make sure you can in my math lab. That would be 3 square root of x squared minus 9 over x squared minus 9.